Hello, and welcome to this presentation, Decoding ARINC 429 with MXO series oscilloscopes. In this presentation, we'll show how to use Rohde Schwarz MXO series oscilloscopes to decode ARINC 429 serial data. This presentation assumes a basic familiarity with the operation of MXO series oscilloscopes, as well as a basic understanding of the ARINC 429 protocol. If you're unfamiliar with either of these topics, or if you'd like a brief review, you might want to watch the presentation Getting Started with MXO Series Oscilloscopes and/or the presentation Understanding ARINC 429 before beginning this presentation. Rohde & Schwarz MXO Series Oscilloscopes support a wide variety of serial decodes, and ARINC 429 decodes are enabled by software license K530. Decoding can be performed using any of the analog channels. In addition to basic display and decode of ARINC 429 serial data, the MXO also supports numerous other useful functions. Words can be shown individually or in a table, and user-friendly or humanly readable labels can also be easily imported. The MXO can trigger and filter based on ARINC 429 field values or on error conditions such as parity or gap errors. Decoded frames can also be exported in a variety of formats. The first step in decoding ARINC 429 data with the MXO is to select Bus from the list of items in the bottom right corner of the screen. Then select ARINC 429 from the list of available protocol types. This will also create a small box labeled ARINC 429 in the signal bar near the bottom left corner of the screen. This box can be used as a shortcut for configuring ARINC 429 parameters. The next step is configuring the source channel, and this is done under Setup. As you should already know, ARINC 429 is a differential bus consisting of two wires called the A leg and B leg, and these wires can be probed in two ways. A differential probe connected to both legs is the preferred method of probing the bus, but in some cases, a single-ended passive probe can also be used. This probe is connected to only one leg of the differential pair, and the polarity setting is used to select which one. The probe type and parameters are chosen and configured through the standard MXO channel configuration menus. Next, let's look at how basic ARINC 429 parameters are configured. The first of these is the bitrate mode. Recall that ARINC 429 has a high bitrate mode of 100 kilobits per second, as well as a low bitrate mode of 12.5 kilobits per second. Another basic parameter is the minimum synchronization gap, or the minimum number of bit times between words. On the MXO, the default is set to the standard of 4 bit times. It's also possible to enable or disable checking of the minimum or maximum gap between words. That is, whether violations of these times should be flagged as errors. Before starting decodes, it's always a good idea to first check that the ARINC 429 signal or waveform is correctly on screen. In this example, the ARINC 429 bus signal appears on the screen with appropriate vertical and horizontal scaling. The most common issue in serial decoding is incorrect vertical and horizontal settings, such as the wrong time base or incorrect volts per division settings, so it's best to visually verify that these are set appropriately. Another potential issue in serial decoding is too small of a sample rate. At least 2.5 times the dot clock rate is the standard recommendation, but note that even for high-speed ARINC 429, this would only be 250 kilobits per second, which is still rather slow by modern standards. After verifying that the input channel levels and time base are configured properly, the next step is setting thresholds. These are voltage values that differentiate a logical 1 from a logical 0. Here, the upper threshold is set to 4.5 volts, and the lower threshold is set to minus 4.5 volts. Enabling Show Threshold lines can make it easier to determine whether these thresholds are configured correctly for the measured bus signal. Once thresholds have been set properly, decoded ARINC 429 words will be displayed together with their analog waveforms in the upper portion of the screen. The lower portion of the screen contains the result table, which shows summaries for all of the decoded frames within the capture. The display settings can be customized in a variety of ways. The decode table can be turned on and off, and we'll look at the decode table more closely on the next slide. The decode layer, shown along the very top of the screen, can be set to off or to several other formats. ARINC 429 uses return to zero encoding, and the ternary symbols, that is, -1, 0, or 1, can be displayed above the analog waveform. Alternatively, the interpretation of these symbols as bits, that is, logical zeros or ones, can also be selected. The default format is showing the data as entire words, with each field having a different color. These fields can be displayed in different base formats, such as decimal, hex, etc. Rather than viewing ARINC 429 labels as numeric values, it's also possible to display these as more human-friendly labels. This is done using an ARINC 429 label file in CSV format. Each label is on its own line, consisting of the octal label value and the user-friendly symbolic label in ASCII text. Our example here maps the octal value 10 to the label present position latitude. This is then used in the decode summary as well as in the results table. Now let's take a closer look at the decode table, which is typically in the lower portion of the screen and which shows detailed information for each ARINC 429 word. This table contains information on a per-frame basis, including the index, which is the word or frame number, the state, which shows if the word is errored or not, and the start time of the frame. The individual fields within the ARINC 429 word are also shown, namely the label, the SDI, the data field, and the SSM. Note that the parity bit is not explicitly shown, but parity errors will be indicated in the state field. The entire word is also shown as a single value, along with the data rate of the word. Our next topic is triggering. Although it's possible to trigger using only standard waveform type triggers, the ARINC 429 software trigger provides advanced functionality. To configure this, we must first configure a standard trigger type, such as an edge trigger, and then an ARINC 429 specific trigger. This software trigger can be configured to trigger on specific word types and field values, as well as to trigger on error conditions, such as synchronization gap errors or parity errors. Let's look at an example. Here we've configured our ARINC 429 software trigger to trigger on words with a parity error, and the capture therefore triggers on frames that contain an incorrect parity bit. Filtering is similar to triggering in that it identifies frames that meet certain user-defined criteria and then only displays those frames. As with triggering, the specific ARINC 429 fields or field values can be selected and configured for use as filter criteria. Filtering only on different error types is also supported. Note that the values for a field can be entered as specific values or as a range of values. Here's a quick example. With no filtering applied, our decode table shows ARINC 429 frames with many different types of labels. Applying a filter for octal label value 125 or 55 in hex causes the decode table to only show words matching this specific label value. Before we conclude this presentation, it's worth noting that decoded results can be exported by choosing Export Results from the Shortcuts menu. The supported export formats include HTML, CSV, XML, and Python. The CSV example here shows the type of data included in the export, timing information, as well as the decoded values for each individual frame. Let's end with a brief summary. The K530 serial decode option enables ARINC 429 decodes on MXO series oscilloscopes. All ARINC 429 protocol parameters are user configurable, and decoded data can be displayed in various formats, both with the waveforms and in a decode table. The MXO also supports a wide variety of trigger and filter types, such as specific values or ranges of values in the frame fields, and/or on frames having different types of errors. A label file can be imported to show more human-friendly labels. Decoded serial data can also be exported as CSV, HTML, and a number of other formats. And finally, remember that it's a good idea to check basic oscilloscope settings, such as levels, thresholds, time base, etc., before beginning decodes. This concludes our presentation, Decoding ARINC 429 with MXO series oscilloscopes. If you'd like to learn more about serial protocols, decoding serial signals, or Rohde Schwarz oscilloscopes, please see the links in the video description. Thanks for watching. Please subscribe to our YouTube channel and visit us at rohde-schwarz.com.